In this video, we're going over populating next right pointers in each node too. So given a binary tree, each of the nodes has this following structure. So the value, the left and right subtree, and the next pointer. So we're populating each next right pointer to point to its next right node. If there's no next right node, the next pointer should be set to null. Initially, all next pointers are set to null. So in a follow-up, you may use only constant space, and also the recursive call stack memories are counted as constant space. So in our first example, we have the following tree, and we're trying to connect each node to its next right node. So in the following node, in the current node of 1, we do not have a next node, so we set it to null. And then 2 has it connected to 3, and 3 connected to null. And the 4 connected to 5, and the 5 connected to 7, and 7 connected to null. Let's go over the thought process. We will be implementing a level order traversal for each of the node x. We will want to connect the children nodes of x. So we will need to keep track of the previous children node, which we consider as prev, to connect to the current children nodes of x. So for example, if we have x.right is not equal to null, we will want to set prev.next to x.right. So for example, if we're currently at 3 here, consider this as x, and then this is our x.right, and then we want to check if this is a previous node. In this case, the previous node is going to be 5, and then 5 need to connect it to 7. And we also have, if we're currently at 2, and this is x, we want to connect, we have x.right here, and then we want to check if this is a previous node, which is go to 4 here to connect to 5, so prev.next to x.right. Then we can traverse rightward to x.next. So basically, after we're processing the current node, we want to go on to the next node at the current level. We should also note that this case will also apply to x.left. So if we currently have x.left here, if we currently at this node is x, and then we have x.left, we want to check if there's a previous node that want to connect to 4 here. And similar here, for example, if there's a node currently at here, we want to keep track of the previous node, which is the 5, and want to connect 5 to the current node to x.left here. Let's go over the pseudocode. So we're going to create a variable node to keep track of our current location inside the input tree. So it's going to be initially equal to roots, while node is not equal to null. This means we still have nodes to process. We're going to create the following variables. The first one is going to be left. It's the leftmost node on the next level. Because we want to perform a level order traversal, and we want to start from the leftmost node for each of the levels and then go rightward. So for example, we're going at 1 and then we'll move rightward, and then we have a 2 and then we want to go rightward, and then we have 4 and we'll go rightward. So we will need to keep track of the leftmost node on the next level. So we also have the previous children node or child node, and then we also have an x, our current node, at the level. And then while x is not equal to null, we want to connect the children nodes. So if x.left is not null, then if left is equal to null, this means we have yet to find the leftmost node on the next level. So I'm going to set left to x.left. Then we need to check if previous is not equal to null. We want to connect previous to the current child. So set prev.next to x.left. Then we'll set previous to x.left because we want to move forward. Else we have yet to find a previous node. So this is the beginning or the first previous node or the first children node at the level. So I'm going to set prev to x.left. Then if x.right is not null, if left is still equal to null here, this means this is the first node that is not null at the next level. the leftmost node at the next level that is not null. So I'm going to, if left is equal to null, so I'm going to set left to x.right. Then also if previous is not equal to null, this means we will need to connect the previous node to the x.right. So we're going to set prev.next to x.right. Then we can set prev to right, update our previous node. Else is going to be the first children node at the level. So I'm going to set previous to x.right. Then we want to move on forward to the next node. So we're currently at x here. We want to move on to the next node at 3. So I'm going to set x to x.next. Then after we process of the children nodes at the current level, so we finish processing these nodes here, we want to move on to the rightmost node at the next level here. So we want to set node to left, and then we can return the roots. Now let's go over time and space complexity. For the time complexity is O of n, where n is the number of nodes in the input tree. We visit each node once, and then space complexity is O of 1 because we use the iterative approach. Let's go over the code. So we're going to create a node to keep track of our current location inside our tree. It's most likely going to be the current starting leftmost position of our tree. So while node is not equal to null, we want to create the following variables: left, which will keep track of the leftmost node on the next level that is not null, and then we have our previous node, initially node, and our current location at the current level, so it's x equal to null. And then we'll have while x is not equal to null, this means we still have nodes to process. We want to check if x.left is not equal to null. We'll first want to check if left is equal to null. This means we have yet to find the leftmost node on the next level that is not null. So we're going to set left to x.left. Then if previous is not equal to null, then we can connect the previous node to the current left child. So prev.next is equal to x.left, and then we can update the previous. Else is the first node, is the first children node, so I'm going to set prev to x.left. And then we'll do the same thing for the right child. If x child right is not equal to null, we want to check if left is equal to null or not. If left is equal to null, this will be the first node that's non-null in the next level. So left is equal to x.right. And if previous is not equal to null, we can connect the previous node to the current node. So prev.next is equal to x.right, and prev is equal to x.right. Else is going to be the first node that's non-null, so we're going to set previous to x.right. And then we want to perform a level order, so we want to move on to the next node at the current level. So x equals to x.next. After we finish the next level, we want to move on to the next level, so we set node is equal to left. Then we can return roots. Let me know if you have any questions in the comment section below.